This episode of the Unbuild It podcast is brought to you by Huber Engineered Woods. When we talk about Huber Engineered Woods, you know, we say they make Advantech, we say they make Zip System, you know, they have liquid flash and subfloor glue and tape. And I think that most of our listeners are fairly familiar with their product lines. They make really high quality stuff that makes our job easier. But I also wanted to let you know that they have a couple of new products on the market that they just announced at IBSX for 2021. They have Advantech X Factor, and they have a new vapor permeable tape. And I think that those things are very important because they go to show what Huber Engineered Woods is really about. They're innovating and they're problem solving before even builders like myself have asked for those things. That process of innovation has kept them at the top of the game, at the top of the pile, and that process of innovation has caused builders like myself who are focused on durability and energy efficiency and really doing things the right way the first time to believe in them as a company and to use their products. We've been using their original Advantech formula since the late 90s as a company, and we've been using Zip System since 2013. So I think that proves to you my belief in the company. I hope that you'll look into Huber Engineered Woods, and thanks for sponsoring the podcast.
Good morning, Unbuild It podcast. Steve Baczek live on YouTube from the Unbuild It studio. I got my good friend Peter Yost.
He's got his third cup of coffee.
I'm still shell-shocked here.
And my good friend Jake Bruton.
Cheers.
And I am a happy camper today because we get to talk about AGW 101. What is that, you might ask?
Is that a grocery store?
No, it's above grade walls. One of my favorite topics, right? How do we build the house? What does that shelter actually look like? And how do we build it? What do we make it up in? Because there are so many decisions, right? I mean, you could build a house out of ICFs if you wanted, right?
Yep.
Or we could do it out of wood.
I think this is the parrot shirt talking.
Normal.
It makes me happy. The Margaritaville shirt. It's the Margaritaville shirt. Man.
Not
but
sponsored.
anyways.
Not sponsored.
It's not sponsored, no. Hey, I don't think he needs a sponsor. Quite honestly, I think he's doing just fine by himself. What's his name?
Jimmy Buffett.
Jimmy Buffett, yes. Never had the chance
I think we're going to talk about Jimmy Buffett today.
Hey, we bring it all here at the Unbuild It podcast. Our spectrum analyzation is far and wide.
So does above grade mean better than average, or does it mean like above the grade?
It means above the grade, above the ground wall system. It is everything that happens above the foundation wall, but below the roof.
Okay.
So it's the in-between.
It's an in-between.
Nailed it.
It's the in-between assembly, right? So getting to above grade walls. I mean, one of the most interesting things that I like to talk about is we've been building wooden walls for, 300-400 years in this country, and we still really haven't figured out how to do it right? So that's pretty amazing feat by us. But I think that, we could start with the standard where we've kind of fallen into that most places in the country, it's a 2x6 wood framed wall, 16 inches on center. You put cavity insulation inside, you sheathe it, you put some type of siding on it, you put drywall or a finish on the inside, and we call that home. But the reality is that's pretty much far from what we know is possible, right? There's a lot of things that we can do. It calls to mind that a while back I did that one detail called the slider detail.
What's the slider detail?
So the slider detail is a detail that I drew that basically is a multitude. What's that? How would you say that? Is it
Bunch.
Yeah,
A bunch.
A bunch, good. And I always appreciate you have the ability to just dumb it down and take it to that kindergarten
We want
language.
everybody to follow.
There we go.
No fancy calendar of the day or word of the day calendar words today.
I got myself in trouble on that one, going down that road. But anyways, so it's a bunch of walls wrapped into one. And when I say that, it's drawn as a 2x4, a 2x6, and a 2x8 wall. So it has some expansion capability in the wood frame. And then on the outside, it has 1-inch, 2-inch rigid insulation that you can expand the outside. But it really, what it does is it helps us understand that there's basically 3 areas that we can approach above grade wall system in wood framing. We have the exterior rigid insulation that is a continuous sheet good on the outside of the stud frame. And then inside the stud frame, we actually have the option to do an impermeable insulation, and we have the option to do an air permeable insulation. And I'm not saying we have to do both, but we have them as options. And we can talk about what those options are and why would we draw it, or why would we do various options there. But it basically allows you to look at that detail and say, okay, I'm in Austin, Texas. I don't need a 2x8 wall. I probably don't even need a 2x6 wall. I can get away with a 2x4 wall, but I might want to put R6 on the outside and then just fill it with an air permeable insulation and call it a day. Or I can take that wall and move it up to New England and I say, let's bump it up to a 2x6 wall. Let's put 1.5 inches of rigid insulation on the outside at R9. Let me splash the inside with 1 inch of closed cell and then fill the remaining with a blown rock wall or something. And that would be a really good wall system for New England. But that slider wall allows us to kind of put a sliding scale on wall design.
I think that location is something that like we kind of glaze over when we talk about choices. We just go, oh, well, it's not as big a deal in South Florida or whatever. But one of the things that, and I don't remember, I was talking to a builder at, I think, Fine Home Building Summit, and I heard him say it to someone else in our conversation. I was just like, oh, that's the best way that I've learned to think about it when we talk about the delta T, the temperature difference between inside and out. And he's like, well, where I live in the northern United States, it might be a 90-degree temperature difference between what the client wants the house and what it is outside. But if you go to South Florida, the most you're going to get is like 45 or 50-degree temperature difference. And I was just like, oh, I hadn't really thought about it from a delta T perspective that simply before. Because, you're not going to get over 120. You're going to get to 105. And then down to 72, but from 72 you might get to negative 20. So there's that. I feel like we glaze over that sometimes, but since we're 101, that's a good this is why we make different choices.
Yeah, why we make different choices, but it also is, when I explain basic wall insulation, etc., to me it's a two-headed monster. You pay to take energy and convert it to either heating or cooling. And so there's that cost. And then there's the cost of how long do I keep it, right? How long do I withhold it? So even in Miami, it might only be 45 degrees, but in some cases, the cost of converting that energy is moving it through electrical, right? So you're buying electricity to convert that energy, which in some places in the country is a lot higher than other places.
Mm-hmm. I pay 11 cents.
Yeah. I mean, up on the Cape, we're at like 22 or 24 cents. So PV makes way all kinds of crazy more sense up there. But it also costs a lot more, to do air conditioning than it does necessarily to do heating, because the return on that investment of energy to convert it just costs more because it's electrical. And so, yes, you might have a smaller delta, but in some places it might cost more to convert that energy. You want to hold on to it a little longer.
It's also funny that we started this conversation. I mean, it makes sense to start with the slider detail that you're talking about, but we started this conversation with insulation, and we always talk about it as the last control layer that we talk about. But when you start to frame a house, the first thing you have to do is decide what stud you're using and what's going on the outside of it. So it is kind of like, well, that's the way
by
we build
default,
it.
if you ask somebody, what kind of wall are you building? Oh, I'm building a 2x6 R21 wall.
Yep.
It's like the R value is right there in the title all the time. Or I'm building an ICF R23, wall system.
I didn't know you could do that with ICF.
Me neither.
Maybe we'll do an episode.
We should really talk more about ICFs.
Yeah. Especially to above grade walls.
Yeah. So, Pete, you've been awfully silent. Talk to me about above grade walls.
Well, I think it's interesting that there are places in the world where they would just be laughing at us for building above grade walls out of light frame, wood systems. But that's the way that we have historically built walls above grade. And it doesn't, it's interesting to look at this from the perspective of what are the things I'm trying to accomplish to separate the outside environment from the inside environment as soon as we get above grade. And, Steve, you love to say this. I really don't have any skin in the game of how you do it. Just do it well, no matter which way you do it.
It's important that, and I think part of this is born of just as an architect, right? My professors never really cared about the end product. So like we could work all semester on a project, we pin up our project, and then we would talk about our project with a panel of critics. And
I was going to say we call that a critique, but we were avoiding big words today. Sorry.
And both of my kids are in architecture school, and I challenge them with the same thing. But the idea is the person up there talking about their project, the project isn't right or wrong unto itself. I mean, you can look at it and say, yeah, hey, that's a really cool building. But the whole purpose of architecture school is, did you start at some point and develop that project with an understanding that you now feel confident about what it is that you have drawn? So I think it's the same thing that, like you said, it doesn't matter which wall we build, but do we understand why we built that wall? What were our intentions? And did our execution come back around and validate our intentions? That's what's important, right? I mean, we talk about it all the time. It doesn't matter how you draw the detail, as long as you know what the hell you're doing when you draw that detail and what is your intention and was it validated with the execution.
We certainly are getting an awful lot interested in walls other than just light framed wood walls because of the cost of lumber. And so we get questions about SIP construction all the time. I mean, this is 101, but to us, yes, we have built out of structurally insulated panels, and you could either build them well or not well, and that's a large part of how they're going to succeed or not. But I hate to say it, it always goes back to the 4 control layers. We talked about it below grade. We're going to talk about it above grade, that how you manage water, air, vapor, and thermal is going to determine whether you have a successful above grade wall assembly or not.
So you and I, Peter, drove past one. We didn't get particularly close, but we talked about it. We drove past a SIPS house that's going up close to the UBIP studio. We can look at it after we're done recording. We should drive by it today. They're putting up SIPs, and they're using it, because I know who the architect is, because they're trying for a really good air sealing. And they're also using a woven house wrap. They're using the bottom of the barrel contractor. I hate the fact that contractor grade meat's the worst crap that you can buy for some reason. The Lumberyards branded house wrap. And it's like, oh, so we made one decision.
Let's just call it the least successful grade.
They should call it that, yes.
The least successful grade.
But like all these conversations stem from that. Like, what are you screwing up? What are you... Why did we make this decision versus that decision, right? We always talk about that. And I think it's really funny that we should remember that you can screw up any one of these assemblies that we're talking about. I mean, maybe not ICF, maybe the other ones, but you can screw up a perfectly good framed exterior wall with poor detailing.
I think one of the important aspects of walls are, because we have such a long history of wall wood frame walls, and I'm going to say probably 400 plus years. The oldest house I worked on a house that was built in 1690. It's the oldest house that I've ever worked on. It was actually pretty incredible to slowly take it apart and see the framing structure and how they did the plaster. There was actually corn cob stacked in the wall to be a wind
still doing
deterrent.
that when you started in the industry, Pete?
1690.
Pete, as a kid, his job was.
I know you weren't born in 1690, but mid 1700s, they're still doing the same stuff, right?
You were stacking corn cobs as a kid in the walls for framers, right, Pete?
Yeah.
Pete, get more wall here. Get more corn cob.
Sorry, you just woke me up.
We should point out to the listeners and the viewers that this comes from a place of love. And that place of love is Steve and I's love of picking at Peter for being older than dirt.
Well, we do have like 120 years of experience. Jake's got 3, I got 4. And
So now that we're talking about age, I have to talk about Michael O'Brien from Virginia Tech School of Architecture has a great paper called The 5 Ages of Wood. And it's a really cool one because it starts with laying logs flat, horizontal, right? And then we moved into timber frame. And then from timber frame, we moved to light frame. And it has a great subsection on why we call it balloon framing. That term.
Is this paper available?
Yeah.
This is the first time I've ever heard you talk about it.
Same here.
Oh, it's
I thought I knew everything that you like to
note
share
to
with
self,
people at this
email
point.
Jake and Steve, The 5 Ages of Wood.
email. Oh, is that like social media?
Pony Express, is that where we're headed? Okay, so that's 3. What are the next 2?
So then dressed lumber, right? And then reconstituted materials. Yeah, and it's pretty cool because the term balloon framing, as we move off the East Coast and we went west, we got to smaller trees, and in order to stand a timber frame, it takes, like 50 people.
Yep.
So we actually moved to lighter frame construction, balloon frame, because we had smaller trees to cut down and there weren't as many people to stand up the wall sections. So the timber framers invented the term balloon framing to describe, if you really want to build
You're making it out of a balloon.
you're making it so light that it'll just fly away like a balloon, right? Because they felt threatened by the fact that timber frame was made with joinery, and that was a craft compared to connecting things with nails. It's a great article, by the way.
Well, what's funny is
I'm glad you brought it up finally.
where I was going with my argument, you dove right in it. We've had 400 years of building with wood, which means we have 400 years of arguing our position to do this versus that, right? I mean, how many times have we heard you don't want to build that wall too tight, right? You don't want to do this. You don't want to, the walls need to breathe, right? All of these things, because we have all this history. It's real easy to go back and say, well, see, I've been building 2x6 walls and putting, house wrap on the outside. My houses don't have a problem. No, they don't have a problem because the energy that you pay all winter long bakes the wall like an oven and keeps it dry. So even if you did have a problem, you're just paying you're solving it with dollars from the boiler. The fact that your windows leak and they're not flashed properly, right? So you have that argument. But as we move into this arena where we're trying to build better homes, and just by virtue of doing things like people using spray foam, they're not getting that baking dynamic that we've got, in say the post-war era housing of the 50s, 60s, and 70s. Those inefficient houses that were saved because of their inefficient construction methods, even now, because with people not doing, say, the most efficient, but they are still tightening up houses. I mean, if you take a house and you just blow open cell in the walls, you've effectively changed the dynamic of that framing system and made it a little tighter. So if you believe that walls got to breathe and then you're doing, or don't have to breathe, and you're doing that, then you really need to understand what your intention is. It's kind of like, your SIPS guy with the least successful house
Water
wrap. It's like,
management
let me put this system in because I want to put my house in a position for success, but then let me apply all the subsequent decisions as the least favorable to success. It's like your intention is blown out the window. That you have no argument.
It's not a holistic approach
for what you're trying to do.
Part of what we're talking about.
Exactly.
Steve, you just slipped really surreptitiously into your above grade wall, things called windows. And, even though this is 101, we're constantly working through the issues of the performance of the glass compared to the performance of the opaque wall, and also how much glass, what type of glass. So when we talk about above grade walls, since, somewhere between 12% and 30% of the wall is going to be glass, it's such a huge part of building above grade walls.
And it will always be the worst part of the wall. Right. Well, I mean, even if you built a 2x4 wall and put fiberglass insulation in it, chances are it's performing better than the window that is cut inside. Right.
Do we have a good resource for people to pick windows? Sure we do. Efficient Windows Collaborative, efficientwindows.org. So we should all read Michael O'Brien's paper and then go look at Efficient Windows covering that.
You're just loaded with references today. It's Peter the reference guy.
Yeah, well, it's 101. We want to make sure you give people the best references.
It is. So I tease you, but that's one of the many things that I commend you about is that I just don't have the initiative or whatever it is to remember all of this information. And it's like, if I want to know something, I'd call Peter.
So I had this conversation. I think we talked about this too. I had someone say, "Hey Jake, it seems like you're fairly well versed on like building science and stuff like that. What books do you recommend? Like what resources do you recommend for somebody to be able to educate themselves?"
Take Pete to Bermuda for a week and just sit on the beach.
I said, befriend Peter Yost. Figure out how to be friends with Peter so you can call Peter and go, hey Peter, how's it going today? Hey, I was thinking, and then
I got you on the phone.
I got you.
I'm working on a small project.
Do you mind helping me run some numbers in a Wolfie model? You got time for a Wolfie model today?
Well, we're doing this 101 for below grade, above grade walls and roofs.
Don't give away. We haven't recorded roofs yet. It's not going to publish till after this.
We don't want to tell people there's roofs.
That's all right. Spoiler alert. Way to go, Pete. Let that right out of the bag.
Maybe don't be friends with Peter. I don't know.
There you go.
If we're going to, come on, where Steve and I cut our teeth on high performance buildings and building science, just go to buildingscience.com. I mean, they have a section called designing. No, it's not designing exterior walls. It's walls that work.
Yeah.
I think that's the section. And it's all climate tuned. So if you're, this happens to Steve and Jake and I all the time. We get through, say, doing a 101 on above grade walls or a 2-hour training on it. And at the end, people say, all you've done is thoroughly confuse me and made me afraid to do anything. Mm-hmm. Can't you just tell me what to do? And when people say that, and they're, it is easy. I remember after Joe got done doing his first 4-hour lecture on above grade walls, I ran to my brothers and I said, we need to change our last name. Because I just learned how worried we should be about the way we've been building. So if you, and that happens, I think, to all of us, we hit that amount of information where we just sort of glaze over. And it's reassuring to be able to go to buildingscience.com and you can look at exemplary best practices by climate so that when you need the comfort food of, give me some examples of reasonable and well-designed walls, well, you can get it by climate.
Well, but you know what? That just drives us right down Easy Street, right? And by Easy Street, I'm going to bore both of you like I bore my daughter in the office. Let's talk about control layers, right?
Let's not turn it into... make us watch Top Gun again today.
What do you got against Top Gun? It's like the best movie. It's U.S. military. Oh, so you want to come down on the U.S. military? So the U.S. military just isn't good enough for Jake, right? You hear that? Everybody in the Navy, Army, Marine Corps. Jake doesn't like the military. He thinks military movies are stupid. No, you did.
No more caffeinated for this guy.
You did. But hey, way to go. Just come down on our U.S. military, Jake. We don't need them. Your freedom and safety it doesn't need to exist. Yeah, way to go. That's good.
Way to spit on the flag there, buddy.
Yeah. Why don't we we'll just have a flag burning ceremony here for you, Jake.
Now, where were you?
It's the shirt. It's the shirt. I'm telling you.
It's the shirt and the 5 cups of coffee.
Let's go down Easy Street, and I'll bore you guys like I bore my daughter in the office. It's not rocket science. It's building science. So when we're talking about above grade walls, yeah, there's a plethora of information out there. Yeah, I know you like that one. I threw that one out there. And with that information, and you said it best when you say it's like drinking water from a fire hose, right? There's a ton of information there, and I can't get it all. But where do I start? You start with a simple rule book and a simple plan. And you look at the above grade walls and say, okay, what do I need to be afraid of? I need to be afraid of water. It's the number one killer of buildings. I need to be afraid of air because it's right up there behind water. I need to understand the vapor. What?
Zombies? Is
Zombies.
next?
Zombies. Okay. No, zombies is number 5.
Okay.
And
thought it was there. Sorry.
I need to be aware of my vapor profile. Notice I didn't say I need to be afraid of my vapor profile because I'm going to go on my little rant later about vapor and the big old bad vapor monster that exists out there. And then lastly is the thermal properties of the wall. And that's number 4. Those are in the orders of importance. So we've established what we should be concerned about. We've established the order of importance. So let's just talk about walls in that regard and just walk through it, because at the other end of it, we're going to come out successful. We have a simple plan. Let's just simply execute it. Unless you want to be like Jake and we could just bash the military all afternoon. But so when it comes to wall systems, water management, right? What's the most important thing? Get rid of it. Get rid of it. If water is on my wall, have it go down, use gravity, use physics in my favor, and get rid of it. Any water that stays, and notice, and I'm going to throw the ball into your court, Jake, we call it water management. We don't call it water barrier. We don't call it the water keep away thing. We call it water.
I like water keep away thing from now on.
So
this is part of our water keep away layer?
No, it's water management. It's like anger management. I think that's a good transition right now. Don't you think, Jake?
Maybe a deep breath. Maybe a little pause. Maybe decide to cut back on the caffeine a little bit.
Wait, I'm gonna come back. Well, when we come back and do roofs, I'm bringing my Marine Corps hat just in defense.
Talking about things that we're supposed to be a surprise.
Oh, I'm just kidding. No, he already ruined it.
I know.
Okay, I'm just playing up on the ruination
right. We're managing.
I should have kept a lid on the topic of roofs.
We haven't even started the roof podcast yet. And he's making puns for the roof podcast.
I mean, I wish I could top that off.
Oh man, Steve! More coffee for me.
So that I can get my composure back and talk to you two about what this is about. Can we put a stop to that? Right. No,
I'm getting serious right now.
But I mean, we're not going to make it not rain. We're not going to be able to stop the water from touching the house. I mean, maybe in the roof episode we can talk about the water not touching the house anymore. But we have to plan for worst case scenario. Well, not Noah's Ark worst case scenario, but worst case scenario in your climate zone. And so we're taking that proportionate approach to manage it as best as we can. If we don't see, what is the breaking point, 20 inches of water a year? Yeah, maybe we're not going to argue for a rain screen. But pretty much everywhere else we are, because we want drying. We're going to argue for overhangs. We're going to argue for properly installed windows that manage water. We're going to argue for taking care of things before they become a problem, not letting them inside the house. All those little control layers, all those little hopeful barriers need to align in a way that manages for water and air and thermal vapor.
So I just have to interject here that we just 30 minutes ago were looking at an above grade wall that required water management in the shower.
Yes.
Right?
Yeah.
And I actually calculated once.
So let me paint a picture for our listeners.
Shower was not
no,
turned
no, no,
on.
no,
The
no. I
shower
want
was
to make a
not
couple
turned-
things clear, please. I was out here behind the closed door to the bathroom. Peter and Jake were in the shower discussing water management. So go ahead, continue.
We had all our clothes on,
Yeah.
right?
Peter has his camera.
Well, I don't know. I was
Isn't
behind the door.
Isn't
but
it interesting
I will
that
trust you.
we say that if it's less than 20 inches of rain a year, you can face seal an exterior wall. But if it's more than 20 inches of year, you should drain it and not seal it at the surface. In a shower, what's the equivalent rain exposure?
Yeah.
It's like 1,000 inches a year. Yeah. And yet every shower except Jake's is designed face sealed to try to control that water. Jake, your shower is built like an exterior wall.
That's exactly correct.
Jake for Shower Designer of the Year.
There's a little tear trickling down my cheek, which is, by the way, water management.
So when I talk about manufacturers that I trust the most and that I love their products, it's Zip and their systems approach to managing water, where everything is one manufacturer, one warranty, it's all engineered to work together, and Schluter, which is behind our tile. It's our waterproofing. It's all one manufacturer. They make the thin set. They make the membrane. They make any sealants that we have to use with it to make sure that it's sealed. And we do the exact same thing. We put a cladding on to protect the zip, which is our control layer, and we put tile, or in this case, wood, on to protect our waterproofing layer. And it's super simple. And I think it's oversimplifying it even to say, like, they're the same thing. I don't want that water to destroy my house. That's it.
Very cool. But so in terms of knocking things about, it was a big revelation to me as a carpenter that the cladding is not there to be my primary defense against water, right? And so it's a water managed system, but the management is occurring behind the cladding. And that completely changes the way I think about, trim boards and corner boards and the cladding, because I've shifted the thinking to I'm stopping the water or managing the water behind the cladding. Well, that completely changes the way you think about above grade walls.
Well, I'm going to militarize this strategy, right? Yes, I am.
Wow.
But when you think of it, you have all your people out there fighting the battles, like all these little pieces of your water management strategy. But you have this zone that is the Alamo or the end of the road. Like, this is where
Draw the line.
Where I draw the line, where the war ends. If I fail here, the war is over, right? But in front of that is where you're fighting all the little battles. You're fighting UV, you're fighting rain, you're fighting snow and ice and cold temperatures, all of that stuff. But like you said, it's what's happening behind the scenes. That's that staunch stand where this is the end, right? So you have to have that intention somewhere in your wall. So for the example you gave, let me put up a SIPS wall and then put this very low successfully building paper on it that now just allows water to migrate through it, and my SIPS panel gets totally challenged. And the sad thing about things like that for me is that house is never going to have a chance. Never. Day one, you've put it in a position to fail, and it's never going to have a chance.
It's an aesthetically pleasing house that also has very small overhangs too. So it's like it's on one thing. Well,
that's good. We'll get rid of it quicker, and we'll be tearing it down in a few years. But let's move on to number 2, air. Right? We talked about water. Air's number 2. Air, for me, it's kind of a two-headed monster. I want to deal with air tightness from an energy perspective because it costs me dollars if air moves across my wall. On that air stream, I can get moisture, and it can jump on that air train, and that moisture can move, and if it finds a cold surface, it condenses, and then it becomes a water management problem.
Turns into bulk water.
And it turns into bulk water, and it could be inside my wall. So I have to be concerned about it because that's kind of the spy in the military aspect, right? That's the one that got behind the lines that now I have to deal with, right? So Yes, I'm going to beat you up on this forever. You will never.
This is how much Steve loves the movie Top Gun.
Yes.
Now
No,
he's-
I can't believe you bashed our military like that. I just don't believe it. But air, it's a two-headed monster. There's an energy efficiency aspect, and then there's the aspect of what can jump on the air train that can cause a problem, right?
Exactly.
And I'm sure you've seen a lot of building investigations where you get in there and air got in there and it brought a lot of things with it.
He said air train, and you didn't go choo choo, move your hand
Or
up and down
whistle or anything.
Yeah,
Well, I'm limiting my answers to yes or no, sir.
you don't
Based
want
on
to
the
be
way
in
this
the
is
line of
headed.
fire on this. Okay, so we've
Yes, sir.
managed for air.
So we've managed for air.
I'm a little concerned about vapor.
Well, but I'm not quite done with
Okay.
air, because I think one thing that's important is that at least for me, I've been in this game personally, I don't know, 27, 28 years. And when I first started working at Building Science Corporation and that, Joe would point out, yes, air was a problem. Yes, it was. But I think we've identified it as it's a potentially lot bigger problem from an energy efficiency perspective than we ever thought it was, right? That it could potentially really be an issue, that beyond insulation, beyond all that stuff, air tightness is a damn important aspect of what we do. And for people to just disregard it and say, oh, the house needs to breathe, and oh, you don't really need to worry about that. The fact that, I'll let you talk about the new code. What is the new code? How do they address air
Yeah, for those of
tightness?
you who haven't read the 2021 IRC, the update for the air leakage requirement, before it was 3 ACH 50 or less in climate zone 3 and up,
Yep.
and 5 or less, 5.0 ACH 50 for climate zones 1 and 2. And from my perspective, at least, the home builders, NHAB, or National Association of Home Builders, has figured out how to make it 5. So that somebody petitioned and got the entire thing set to 5, which is like a total step backwards. And I hear that and I go like, yeah, but it's 1 in Canada. If the Canadians can figure it out to a 1, why are we moving backwards?
That is sad that we've relaxed it from 3 for most climates to 5 ACH 50.
For everybody, which is
All right. Vapor profile. We're moving on to it.
Wait, can we all shook our heads for those listening. We all disagree with that move, right? Come on, step
Yes.
up your game.
Yes.
We have electric cars, we have solar panels, you have cell phones, you have a computer in your pocket, and we can't
Jake,
get
you have
below-
houses that without air barrier and all of those incidental improvements have gotten under 0.3 and under 0.2. So we can do it. We can do it with the materials that are out there. We don't have to get crazy. We can do it. So if we can consistently get below 0.5, which I think is true for a large portion of the builders, relaxing it to 5 is just stupid.
It's interesting, especially given that it's just not an energy penalty. You're making it riskier in terms of moisture as well. So, yeah, we can lay that one to rest.
All right. Moving on to vapor profile, right? I always talk about vapor profile. Is it a problem or is it an asset? Just everything that I ever hear about vapor is the big old bad vapor monster is coming to get you and you need to put up a vapor barrier. Like, let's build the vapor castle so the big bad vapor monster doesn't come in and get you. It's like, if you manage air transported moisture and if you manage cold surfaces to be warm surfaces, then what is vapor? Why is it a problem? Right?
It's not.
All I was ever taught was vapor is all around us. It's part of the air. There's moisture in the air everywhere you go. And as a vapor, it isn't a problem. It's when it condenses and becomes bulk water that you have a problem. So just keep it in the vapor form. And the way we do that is by keeping it warm and keeping it away from cold surfaces and stop it from moving around through our wall systems. Keep it on one side or the other. Now, the beautiful part of vapor profile, Pete, is that we can use it as an asset. We can use the vapor profile to dry out our wall system. So talk to me.
Yeah, well, it's kind of ironic that we, in terms of doing building investigations and buildings that have trouble with moisture, it's way less than 0.5% of buildings that get into trouble from really high vapor environments. Now, if we're talking about...
Wait, say that again.
We have
how few?
We have very, very few, even in cold climate buildings, that get into serious moisture jeopardy from strictly vapor alone. It's almost always a combination of bulk water and air leakage that creates the problems. Having said that, we also never give our clients an accurate way to measure vapor in their homes. So we tell them how scary it is, but then we give them no way to measure it. That's like the recipe for not success, Steve, right, with homeowners. Yes. But here's the thing. Once the water gets into our building assemblies, well, we can't drain it out. That's bulk water. We can't wick it out, right? That's capillary water. We can't air dry it out. The only way to get it out is to let it evaporate as a vapor. So we don't worry about the vapor permeable building materials because that's the way that buildings get wet. We should worry about the vapor permeability of building materials because if they get wet, the only way they're going to dry is by providing vapor a way of getting out. So we sort of have it backwards. And the code is as guilty as anyone on this monster focus on buildings getting into trouble from vapor, when what we really should be doing is saying, hey, that's the way we got to get them dry if they get wet. It's the opposite.
Right. And I'll piggyback if I think back of all the buildings that I did investigate that was a vapor problem, it was most likely someone putting up a vapor barrier thinking they're keeping vapor out and migrating in, and it got in but couldn't get out.
Exactly.
And the wall couldn't dry out, like a basement wall that was a wood-framed wall with bad insulation, and then they put poly on the wall and drywall. Moisture gets behind there, migrates in from the foundation wall, or just gets behind the poly, and it can't get out of there, and everything turns to a mold farm inside.
So think of it as a rabid raccoon. If it finds its way in, but it can easily get out, it's not going to cause any damage. But if it is trapped, it's going to tear its way through the assembly until it causes damage.
He's just moved from vapor to mammals.
Yeah, I'm not really talking to him. He bashed my military.
Okay, then our the last of our four equations in this instance
is thermal. And thermal's an easy one for me because I always tell people thermal's a financial equation. Put as much insulation as you can afford now into the wall system. And
after spending your money on the other things.
After you're spending your money on proper water management, proper air management. I mean, the code obviously has minimums, so you have to at least do that. But, hopefully we do a little bit more. But if we go back to that slider wall and some of the things that you touched on, Peter, I know for a fact, just because doing stud counting and working in the arena of cavity R value versus whole wall R value, such that a lot of people sit there and say, oh, I build an R21 wall, 2x6 wall. Well, not really, because the windows account for probably 20% and they're at R3. The framing accounts for probably 15 to 20%, depending on how efficient you are with it. And that accounts for a 2x6 is like 5.8 R value. So those two there bring that R21 down. So in a 2x6 16-inch on-center framed wall with an R3 window, you're probably at about R10, R11 for whole wall R value when you normalize those values across the whole wall system.
But since this is 101, I know there are a bunch of folks out there that are saying, these guys are saying the level of insulation is the least important aspect of the building wall performance. I mean, I remember when I went to one of Joe's first presentation, I thought, this guy's got everything ass backwards. And what I didn't realize was that we have it ass backwards.
So, Peter, you bring up a really good point, because one of my favorite sayings about building is, if it don't last, it don't matter, right? So when you talk about insulation being last on our list, but first on everybody else's list, in my eyes, it doesn't make sense to build a passive house wall that doesn't have good water management that rots away in a year.
Yeah.
Right. And that all those resources that we've embedded in that structure are now thrown away, including the R60 wall or R70 wall, because we didn't pay attention to what really mattered. And I think, Joe's been a huge proponent of it for as long as I've known him. And yeah, he's got it right. We need to worry about the things to worry about and then fill in the blanks at the end with things like how much insulation are we going to put in here?
So while it's not rocket science, it's building science, it does turn things topsy-turvy for most of us.
Mm-hmm.
And there are simple
Certainly
rules to
from where I
follow.
started in the industry.
Exactly. So there are simple rules to follow, but they're kind of new rules for a lot of us.
And speaking of new rules,
Yeah, so I have some notes here for a few of the things since we were talking about changing in the 2021.
Oh, excellent.
So a couple of these just apply to my climate zone. We went from an R20 requirement in climate zone 4. We went from R20 or 13 plus 5 continuous to 20 plus 5 continuous and 13 and or 13 plus 10.
Oh,
So they upped the exterior insulation requirement, the continuous. Now,
can you do a
This is
cavity
the-
of
this is what-
R25 or R30?
no, you have to have continuous now.
but how ironic that they upped the insulation requirement and relaxed the air.
Relax the-
So they have it topsy-turvy too.
Exactly.
And our attic requirement went to R60. We were 49 before, and actually, climate zones 2 and 3 went to R49 as well. And I think they were still 38. You don't quote me on that.
I think
they
so.
were.
Yeah.
And our U factor went to a mandatory minimum of 0.40 on windows on glazing. So that's jumping it up from every window that I've ever bought from an American manufacturer.
Yeah, that's kind of sad.
And then the blower door change. Ductwork all has to be, this doesn't have to do with walls, but all ductwork has to be tested now, despite its location.
Really?
So even if it's in the envelope, it needs to be.
And just a real quick plug that we never think of our mechanical systems as separated from the performance of the above grade wall. I mean, I distinctly remember one of my first trips to the Building Science Corporation office with Steve as an architect, sending his plans back and forth to Coda Ueno in terms of Coda evaluating the HVAC performance based on the changes that Steve made in the performance of the wall. So when we talk about how above grade walls work, it's always connected as well to the other aspects of building performance.
And that's true of windows too. It's
True of everything.
Yeah, windows are totally linked to your HVAC system, whether you believe it or not. These aren't independent decisions anymore. Our houses have become so dynamic and inextricably linked that every decision we make has a consequence to a lot of other components that we're putting inside that house.
Which is a perfect lead into, if we're going to talk about the success of the above grade walls, we've got to talk about finally the success of the roof.
Yeah. So let's wrap it up. I'm going to have to say, see you later. I will have a stern talk with Jake about bashing the military once we get offline here and how we shouldn't do that publicly. But I apologize to all my military friends out there.
Apologizing for me, or you're apologizing for your
Well, I'm
behavior? Which is
apologizing
it?
for me associating with you, who is a military basher. Anyways, no.
For anybody that I offended with my Top Gun is not one of the top 3 best movies ever. I still stand by that statement. Grow up. Find something besides Tom Cruise in the 1980s to watch. There
All
are
right, so let's
plenty of
leave it
things
with
that-
this. What is the best movie of the 1980s, Mr. Cinematography
That
Specialist?
is as easy a question as you could ask.
Go
Pretty
ahead.
in Pink. Molly
Oh my
Ringwald.
God, no. All right.
I would say Mary Poppins.
Oh my
There you
God.
Anything with
YouTube.
Dick Van Dyke.
YouTube.
Well, it's got a chimney.
No, we're done. Shut up. YouTube. Goodbye.